After interior of a circle, what we define now is called the exterior of a circle. The set of points that lie outside a circle. A circle is called the exterior of a circle. Called the exterior of a circle. Next, what we define is called the circular region. The set of points the set of points lying in the interior of a circle and on the circle is called the circular region. Okay, the circular region. Now, what do you mean by circular region? All the points that are inside the circle, all these points that are inside, okay, and all the points that are on the circle, all these points that are on the circle, okay, all these points are called the circular region. Okay, next important definition: chord of a circle. Now, what do you mean by chord of a circle? A line joining any two points on a circle is called the chord of a circle. A line segment, it is a line segment joining any two points on a circle
Good morning.
good morning, any two points on a circle, a line segment joining any two points on a circle is called is called a chord of a circle. How does the chord look like? This is a circle. You take any two points on the circle. Suppose I take these 2 points, A and B, and I join these with the help of a straight line. Then this AB is called the chord of a circle. Similarly, you can have many chords in a circle, infinite number of chords in a circle. Okay, so you can write here AB is a chord of a circle. AB is the chord of the circle. Okay, so this is what chord means. We come to the next definition, which is called the diameter of a circle. This time, now you already know diameter, right? You know, but you know diameter is any line that passes through the center of a circle. It's called the diameter. This time we'll define the diameter in terms of the chord. Diameter of a circle. What do you mean by diameter of a circle? A chord of a circle which passes through its center and has the chord of greatest length is called the diameter of a circle, and it passes through the center also. A chord of greatest length which passes through the center of a circle is called diameter of a circle, or let's say E diameter of a circle. So now you have a circle, and suppose this center is O, and if I draw a line through O, this will be a special chord of a circle. Why special chord? Because it passes through the center of the circle. That is why it is a special chord. This special chord is called the diameter of the circle. And this chord will have maximum length among other chords. Yes, so if I say AB here AB is a diameter of the circle with center O. That is the diameter of a circle. Okay. You can have many diameters, not only one, you can have many diameters, infinite number of diameters you can have. Next, what we define is um, the secant of a circle. Secant of a circle. A straight line intersecting the circle at 2 points is called the secant of a circle. This time, the line can be of any length. A straight line, just in case of a chord, you had a line segment, right? If you see a chord here, this was a line segment. That means only this segment, this part. Okay. That is the difference between a chord and a secant. That a chord is a line segment, whereas a secant is not a line segment. A straight line intersecting.
Good morning, sir.
Why so late? Good morning. A straight line
So I was wasting my face, sir.
a straight line intersecting any 2 points on a circle is called the secant of a circle. Let's say a secant of a circle, called a secant of the circle. Now, what does a secant look like? This is a circle. This is how a secant look like. Okay, it has a line of any length. And if you take these two, this line segment AB, then this becomes the chord. But this straight line itself, L, if I call this line L, then this line L is called the secant of a circle. It has no length, infinite length it has. So here L is a secant of a circle. Then take a note here. Note the line segment, the segment AB of the secant forms a chord of a circle. Okay, only this segment forms a chord. Otherwise, this entire line is called a secant. Forms the chord of the circle. Okay. So what is the importance of secant? We'll see later. Importance of secant comes when when I'll be discussing the definition of tangent of a circle. But before going to tangents, let us discuss what we mean by the arc of a circle. Okay. Any continuous part of a circle is called an arc of a circle. Any continuous part, curved part, is called its arc. Okay. Now, so what do you mean by arc here? What do you mean by arc here? Suppose if I take this point, if I take this point as A, and if I take this point as B, okay, then you see this curved part here, this curved part of the circle, this is called the arc of a circle. Okay. In fact, this length, this curved part of the circle is called the minor arc, and this part of the circle is called the major arc. Okay. If the arc is more than half of the circumference of the circle, then it is called a major arc. So you just note this. Note, if an arc exceeds half the circumference of a circle, then it is called a major arc. Otherwise, it is called a minor arc. Okay. So if this is more than half of the circle, see that this part is more than half of the circumference. So therefore, this becomes our major arc. This becomes our minor arc. But the point is, which what do we call the half of the arc of the circle? Okay, that is called a semicircle. That we'll see in here. Semicircle. Okay, semicircle is one half of the arc of a circle, or simply half of the arc of a circle. One half of the arc of a circle is called a semicircle. So that means if an arc is more than a semicircle, then it is a major arc. So how does a semicircle look like? This is one half of the arc of a circle. AB is the diameter here, and this length is a semicircle. Okay. Next, circumference. The entire length of the arc of a circle is called a circumference. An entire length of the arc of a circle is called its circumference. An entire length of the arc of a circle is called its circumference. Circumference, the entire length of the circumference is, this is the entire length of the circumference, and therefore this is the uh, entire length of the arc. Therefore, this is your circumference. Okay. Next, what we define is called the sector of a circle. What do you mean by the sector of a circle? The area that is bounded. Remember, sector of a circle refers to the area. The area bounded by an arc of a circle and two of its bounding radii is called a sector of a circle. So what does a sector look like? You take an arc. Suppose I take AB as a minor arc. This is your center. What do you mean by bounding radii? From the center, let us call this, give the name to a center, this O. And from the center, let's join these OA, and let us join OB also. These two will form your bounding radii. OA and OB are called the bounding radii. Okay, so here OA and OB are the bounding radii. Okay, so what should be the sector? This part becomes your minor sector because this area is enclosed by this arc AB and this radii, bounding radii, OA and OB. So this becomes your minor sector. Okay, and right here, this is the minor sector. And this becomes your major sector. You have OA and OB as the bounding radii, and which is the arc here? The major arc. Okay, so this is your major sector. Okay, so what we see here is the minor sector minor sector is formed by the bounding radii OA and OB and arc AB, minor arc AB. Minor. How do you write arc AB? I forgot to mention, I think. But you arc AB, either write minor arc EB this way, okay,
So
or
you can give the sign on
or
the
you
top.
can simply give a sign on top, or you can simply give a sign on top as minor AB, and you give this kind of. Okay. So minor and the major sector is formed by the bounding radii OA and OB and major arc AB, or you can write in this way also, major AB. Yes. Okay. So this is how we define the sectors of a circle, the major sector and the minor sector. Next, we come to the segment of a circle. What do you mean by segment of a circle? A chord divides, any chord in fact, divides a circle into two parts. Each of these parts are called the segments of a circle. It's called a segment of a circle. Each of these parts is called a segment of a circle. Okay, this is your circle. Take any chord AB. So you see that this chord divides the circle into two parts. This part here, okay, and this part here. This part is called the minor segment, and this part is called the major segment. Okay, so if the arc that is involved in a segment is more than half the circle, then it is called a major segment. Otherwise, it's called a minor segment. So that is what a segment means. Next, very important definition is that of angle subtended by an arc of a circle. Angle subtended by an arc of a circle. Now, what does this definition mean? It's a very, very important definition which we are going to use later on also. Okay, uh, the angle between the two bounding radii, the two bounding radii of an arc of a circle is called the angle subtended by that arc. Okay, so let's see what it looks like to have an angle subtended by an arc. Choose any 2 points, then AB forms an arc here. Let us say this is the center of a circle. Let's call it O. Okay, now what I do is I join these two. So these form your bounding radii. Okay, this this angle here is called the angle subtended by this arc AB at the center of the circle. Understood? The, this angle formed by this arc at O, this red angle that you can see, this angle is called the angle subtended by the arc AB at the center. So we write here angle AOB is called the angle subtended by the minor arc, because AB is the minor arc, by the minor arc AB at the center of the circle. So I'm underlining this minor arc at the center. Next, what happens if I take this same arc? Also, not consider the another point before going to that point. Um, then what is the angle subtended by the major arc AB? The angle subtended by the major arc. What's the what? Which one is the major arc here? Major arc here is this one, right? What is the angle subtended by the major arc AB at the center? Then the angle subtended by the major arc AB at the center will be this angle. Is it clear? Or any questions on this? So this is the blue one, the reflex angle that you see here. This angle is the angle subtended by the major arc AB at the center. So therefore you can write here reflex angle AOB is called the angle subtended by the major arc AB at the center of the circle. Okay. Now I'll just underline this. Now, not only does an arc subtend an angle at the center, but it can also subtend an arc can also subtend an angle at the circumference. Consider the same arc AB. Consider the same arc, this arc AB. This time, instead of taking a point at the center, if I take a point here, anywhere on the circumference, that is accepting this arc, apart from this arc, I'm not taking a point on this arc, I'm taking a point on the major arc. And I join this. then this angle here is called the angle subtended by the arc AB on the remaining part of the circle. Okay. Here, let us call this point P. Here, angle APB. Here, angle APB is called the angle subtended by the minor arc AB on the remaining part of the circle. Why remaining part? Why remaining part? Sonam, tell me why remaining part? Anyone there to tell me why remaining part? Oishi?
Yes, sir.
Why remaining part?
So,
No problem. Remaining part means this is the arc that we are considering, right? What is the remaining arc? This is the remaining arc, this major arc. That's the remaining part of the circle because we are already considering this arc. And what is the remaining part? This is the remaining part from here to here. Okay.
okay,
So
sir.
you can take any point here. That is why it is called the remaining part of the circle. That is why it is called the angle subtended by this minor arc on the remaining part. That is, you can have any point. You can have a point here. You can have a point here. You can have a point here, but you cannot have a point here. Understood? So that is what it means. Okay. So now see, there can be another one. What is the angle subtended by the major arc AB on the remaining part? If I take a point here, say Q, and if I join this, then what is the angle AQB? This one? This angle here? This angle here is subtended by the major arc AB on the remaining part. Now this part becomes your remaining part. Right or wrong? So I'll just write here on top here so that it's there in front of you. Here angle AQB is the angle subtended is called the angle subtended by the major arc AB on the remaining part of the circle. On the remaining part of the circle. Understood? Any questions till this part? If not, then I can stop here for today.